Hi, Assalamualaikum. This is a presentation video that we will discuss the topic about application of differentiation. Let me introduce our group members, which is myself, Nurin Suliana, Nur Izzatu Aina, and Afika Amalia. Let's start with related rate. What is related rate? Related rate is rate of changes associated with two or more related quantities that are changes over time. Related rate also can be defined as the slope of change comparison of two quantities. Related rate involves two or more variables that change at the same time, possibly at different rates. Then, why we use related rate? Problem involving related rate take advantage of quantities that are related to each other. Related rate help to determine how fast and how slow a certain quantity is changing using the rate of the second quantity. Related rates are used to find any rate of change that are harder to determine by two related quantities. The rate of change is usually with respect to time, because science and engineering often relate quantities to each other. The method of related rate have broad application in these fields. Differentiation with respect to time or one of the other variable require application of the chain rule since most several variables.
Next, we take a look for the example of related rates. If we pour water in a vase, the height of the water in the vase increases per unit of time. At the same time, the volume of the water in the vase also increases per unit of time. In this case, the height of the water and the volume of the water is changing at the same time and are related to each other.
If you pour a water into a small puddle, the area of the puddle will increase over a unit of the time. At the same time, the radius of the puddle will increase over a unit of time. Therefore, the radius of puddle and the area of puddle will changing at the same time and related to each other. Water is poured into a conical tank at the rate of 9 meter cubic as -1. The radius of the tank is 4 meter and the height is 12 meter. At what rate is the water level rising when the water reach 4 meter deep? For the solution, we already have the information from the question is dV over dt is m 9 meter cubic as -1. So for the first step, we need to separate the dH over dt and make it dH over blank and blank times with blank over dt. For step 2, we need to fill in the blank space with the given info. The info we have from the question is dV, which is we got from the question here. For the step 3, we need to differentiate the formula. The conical tank's formula is V equal to 1 over 3 pi r square H. For step 4, we need to substitute V using the ratio. First thing first, we need to find the ratio of the V first. From here, we can see the V over H. We get 4 over 12. 4 over 12. And we have the ratio is H over 3. So from the step 3, the formula, we need to put the H over 3 with the R. So it will be V equal to 1 over 3 pi H over 3 H. So when we finish doing the calculation, we will get V equal to pi H cubic over 27. For step 5, we need to differentiate the dV over dH equal to 3 over 27 pi h square, which is we get from the step 4. So it will be 1 over 9 pi h square from dh over dt or equal to dh over dv, and dv over dh we get from the step 2. And then we need to do the full calculation here, and when we finish the calculation we will get 81 over pi h square, and after that we need to put h with 4, so dh over dt equal to 81 over pi 4 square. So we will get the answer here, 81 over 19 pi ms negative 1.
Here are the example question of application of differentiation. Water is poured into a container at rate of 12 cm cube per second. The volume of water in the container is given by V equal to 3 over 2 in bracket h square plus 8h, where h is the height of water in the container. The question asks to find the rate of change at which the height of water is increasing when h equal to 8. So the first step to solve this question, we have to identify the dV over dt, which is equal to 12 cm cube per second. Next, in order to find the rate of change, which represented by dH over dt, we have to multiply the value of dH over dV and dV over dt. The question have given the volume of water in the container, which represent as V equal to 3 over 2 in bracket h square plus 8h. This equation is appear as dV over dH. And finally, we can put all the steps that we just find just now in the equation before, which is dH over dt equal to 1 over 3h plus 12 and multiply by 12. We have to invert the value of dV over dH because the formula is dH over dV. And lastly, the question has given the value of h, which is 8. So we just have to put the value of h in the formula to get the answer, which is 1 over 3 cm per second.
So, the conclusion is related rate problem involves two or more variables that change at the same time, possibly at different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. Other than that, related rate can get the function or equation that we could remember or hardly to understand. So, because of that, we need to learn the topic about application of differentiation in mathematics. End of our presentation. To prepare this video, we use this reference. So, that's all from us. Hopefully, this video is useful for everyone. Thank you for watching.